All right, here we go. Logarithms. They are super fun. You just have to get to know them. They're like the poor misunderstood. Any of you feel like you're misunderstood? Any of you feel misunderstood by other people? That's how logarithms feel. They feel misunderstood. Well, yes, you heard that. I'm going to help you to understand them. I have never been happy with how a textbook has ever presented them. I am not happy with how Common Core is presenting them, although they're doing a better job than the textbooks used to do. Here we go. All right, first of all, you need to understand inverse functions, which we talked about in Unit 1. Now, some things are nicely, have good notation chosen. This does not. So follow me right here. If you have a function with variable x where you know the base, it's a number, but the variable is the exponent. So realize this is different from x squared. This is 2 to the x. We just looked at the graph of that in the last unit. The inverse is we put 3 letters down. Because it's called a logarithm, we shorten it with 3 letters and call it a log. Then the base of this exponential function needs to match the base of the logarithm. However, when you write it, you are going to do a subscript. And with a subscript, you're going to put that base number. And each exponential function, you've got 2 to the x, 3 to the x, 5 to the x. Each one of them has a specific inverse logarithm. So 2 to the x has the inverse of specifically, and I probably should finish and put the input variable. The input variable is on the same line as log. So you write log subscript back to regular script input. For the logarithm to be the inverse of the exponential, the bases have to match exactly. Each of these exponential functions has a slightly different inverse. So 2 to the x has inverse function log base 2 of x. You know how to fill in the table for f of x right here. Right now, I want all of you to be filling in this table. I'm going to erase what I just wrote. So I'm going to look at chat. And if I plug 3 in, what is 2 to the third power? I'm checking chat. 8. What is, if x is 2, what is 2 squared? 4, good. When x is 1, what is 2 to the 1 power? Good, 2. When x is 0, what is 2 to the 0 power? 1. When x is negative 1, what is 2 to the negative 1? When I write it without negative exponent, good, 1/2. And what is 2 to the negative 2 power? 1/4. Now, you are going to take all of these xy pairs and see what you need to understand is the only thing that a logarithm is it's an inverse. It's going to take everything in this table and take the x and y and go whoopoo. So that means one of the points of the logarithm is 8, 3. Another point of the logarithm is 4, 2. Now I want you to finish this table. All of you finish this table. You are capable of reversing all of these. Okay. Now, just to present another logarithm to compare, you thought what was homework? Is it bad that I tried doing this all last night? No, that's fine. I'm walking you through it now. Can I go back up for 5 seconds? Okay. So what I want to do is be able to show you just more than one logarithm so you can just kind of see that they are different just depending on what the base is. Now, very important though with 10 to the x. Do you see 10 to the x written often in science classes? I'm checking chat for an answer. Correct. In fact, is it very common? Is it very common to see 10 to the x in science? Very common. This, can I write? Possibly, possibly not. So log base 10 is such a common logarithm that we don't write the base. Know that if you see a logarithm with no base written, that's like seeing a root with no 2 written. We understand if we don't write a root, that it's root 2. With a logarithm, if we don't write a base, we understand that the base is 10. And the reason is that was the 10 to the x power was the first function that was looked at because it was used so much in scientific notation. Now, science depends on math. It doesn't want to do the math. It wants math to just tell it what to do. While you're in math class, though, you have to try to understand what's going on. So mathematicians had to help the scientists out. And they started by making a giant table for if this is the value of your exponent, what the inverse of that is. What is log base 10? And if you ask your parents, you might be able to find like a nice table of logarithms. In fact, there are book publications of page after page after page that have already had the math worked out. But since the oncome of the calculators, we don't need to use those books anymore. So a guy named John Napier spent, oh dear, I'm forgetting my history now. I don't remember, but exactly, but he spent a lot of years, like at least a decade, writing out the base 10 logarithm table, doing all the calculations before the calculators existed. And then apparently somebody then said, what if the base was another number? Okay, anyway. So this is called the common logarithm. You should know that, be aware of that. This is called the common logarithm. Now, we got some numbers. What is 10 to the third power? What is 10 squared? 10 to the 1? 10 to the 0? Yep. 10 to the negative 1? positive 1/10, 10 to the negative 2, positive 1 over 100. Now let's make a table for the common logarithm. If I input the x-coordinate 1000, I get out 3. If I input into this logarithm 100, I get out 2. And all I'm doing is reversing these points. And I'll give you a moment, and then I am going to scroll. And also know that the answers are posted online if I go a little bit too fast. You can check those answers. Okay, I'm going to scroll so I don't run out of time with you guys. And I need to zoom. Okay. Now, I have this ready to go so that I remember what my intention was. What I want you to see is there are a lot of different inputs. I actually need to have my draw ready. Come on, draw. Okay. This input is basically any x that I choose, and I'm putting it into the function 2 to the x. If I input a 3 into the function 2 to the x, what comes out of it? Yes. Now, we are going to be working with inverses, and we did that back in Unit 1, so hopefully you're ready for this. If this really is the inverse of 2 to the x, if I put into the x of log base 2 of x, if I put in 8, what must I get out just because of who it is? Right, I should be getting out that 3. Now, what's important about this is I want to show you that we started with putting the 3 into 2 to the x. So we started with 2 to the power of 3. Now, that 8, which is 2 cubed, that is an output on f. It is a y-coordinate. But if I decide to then make it an input on my inverse function, that means I'm plugging into this x 2 to the 3rd power, which means that this becomes the input of log base 2. Now, sometimes people get confused or logarithms seem harder just because of how they're written. Somebody chose to use 3 letters and then put a base. We have to deal with it. There might have been better notational choices, but it isn't what we got. So based on this input, output, input, output table, this is supposed to give me an answer of 3. What you need to understand is whatever goes in the exponent of your exponential function, if you take that result and put it into a logarithm that has the same exact base, that's equivalent to, hey, let's add 2 and subtract 2. And you just go back to where you started, which is 3. it also has an equivalence with, hey, let's take 3 and let's multiply by 2 and then divide by 2. Oh, what do we get? But we don't want to waste our time doing an operation to undo it. Right now, I'm trying to have you see what a logarithm is and how it is in inverse. And you want to do as little calculations as possible. Now, I have a reminder to myself. I hope you didn't write show color-coded answers. But that was my reminder to come over here to the answers because I have it set up in color coding that I want to present. So what I want you to see about this is if 3 is an input to the exponential 2 to the power of, 8 is the output. What that means is if I have the inverse function, log with the same base, that process is reversed. 8 is an input, 3 is an output. As you read logarithms, what you can do is you can look at the input and basically ask yourself, I'm going to write some stuff. Look at that number 8 and ask yourself, if I had an exponential function with a base of 2, what exponent would I need to get out the number 8? That's what each of the logarithms is saying. So now let's take a look at these. And I want you to focus on the log side. So focus first right here on this one. And I'm going to color code a little bit here. If I put 10 into a logarithm that has base 10, and I think I'm changing some of my color coding from before, so let me hold on one second. I'm going to use red for this. I'm going to use green for this, and I'm going to use blue on this. Okay. So if 10 goes into a logarithm that is base 10, that's another way of asking, how do I get 10 out? Or what exponent does that base need to be? What exponent do I need to have on this 10 to get an answer of 10? And that would be 1. Now, look at the next one down. And I'm going to color code again. So this is going to be red. Base is blue. Logarithm's input is green. If you see log base 10 of 100, you need to look at for this base 10, what exponent will cause this to be 100? So 10 to what power is 100? And then you see 2, and you get that as an answer. And then again, we have 1,000. If 1,000 is the input on my logarithm, what it's asking is, what exponent do I need to put on a 10 in order to get 1,000? And then you see 3. So what you want to start seeing logarithms as is that answers they are giving are actually just exponents. They themselves give out an exponent. And then what I want you to write in is observe the pattern of switching the inputs and the outputs. Now, the next piece, oh, don't show answers, not yet. Okay, the next piece is, can you look at these logarithm expressions and figure out what number they are? And I'm going to take you through this and color code a little bit. I'm going to make base blue. Whatever number this is equal to, that's the exponent on 3 where I get an answer of 3. So what is A? What is A equal to? 1. So that means I'm going to put letter A here on the number line at the number 1. Now let's move over to B. I'm trying to figure out what is this equal to. So I want to look at the base of the logarithm is 3. The answer to my logarithm is some exponent. And I'm looking at if the answer to an exponential expression is 9. And the exponential expression is 3 to the power of something. What is the power? You can't see those colors? Really? Wait, are they not showing up? Oh, okay. Okay. Colorblind. Help me out. You can see red. You can distinguish red. What else can you distinguish? What colors can you distinguish from red? So if you look up here, you can see red as different from, okay, I'm talking to the colorblind people. How many different colors can you see amongst these colors up here? So blues and greens are the same color to you? Was that it? Can you see the difference between black? Okay, then how about I use black for base instead of blue? And let's see if that works. With finishing up part B, I need exponent 2 on my 3 to get 9. And I'm going to write a B there, and then I will do the color coding on the next one. So this 3, I'm pointing to it with a black arrow. That's the base of my logarithm. So that means the base of my exponential is 3, and it's to the power of something. Whatever that power is, that's the answer to this logarithm. The answer to the exponential is the same as the input of the logarithm. Are you able to see the difference in those colors? Hopefully. Okay, good, good. So when you look at this statement, you should see -1. And so I'm going to come over here on the number line to -1 and put a C. As we go through these first few classworks and homeworks, I'm hoping you'll see why I put Unit 2 in. I needed you to spend more time with exponential expressions to get a better feel for them. so that when you come here to logarithms, you're already seeing the negative exponents because they are making sense to you more than before Unit 2. All right. Then I'm moving on to letter D. And the base I'm pointing to with a black arrow. So 3 to the power of something. I'll put question mark. Is equal to the input of my logarithm. What exponent can I put on a 3 and get 1 as an answer? Good, 0. So if this is equal to 0, then I'm going to put a D on the number 0. You can't tell the difference between green and red? Is it blue and red and black that would be better? Okay, okay. Then one more with E. Okay, I just used a green. I'm going to turn and use another color to hopefully get through all the colorblind problems. Okay, 1/9 is the input on my logarithm. That means it is the output on an exponential function. And that exponential function has 3 as the base. The answer to this logarithm is, what exponent do I put on a 3 and I get a 1/9? What exponent goes on 3 to give me an answer of 1/9? I'm checking chat. Good, 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 good. So I'm going over to -2 and I'm putting an E on that. And this is the rest of class, just different issues. If for some reason I'm not able to get through all of these examples before class is up, I will keep videoing and finish going through these and then post that video. All right, here we go. Now, each one of these is going to get a little bit harder with more issues brought in. So I've got a base 3 logarithm again. So 3 to what power will give me an answer of 81? Maybe that helps. I've got a blue and a green. Good. Excellent. So I'm going to put letter A at the number 4. But now the bases are going to change. For letter B, I have base 10. 10 to what power is equal to 100? 2. Good. So then I am going to put B on 2. C. Do any of you are you at the point where you look at C and you know the answer? Now, that's going to fade in and out. If there are a couple of hours between now and when you start the homework, you might have to start all over again. But look back at this video if you're having trouble. So what is letter C? What is the answer to letter C? Oh, don't give all the answers right away. Okay, 1. Yes. Come on. On D, 25 is 5 to what power? 2. So D is also at 2. I'm just going to put it above it, but however you want to do it. Maybe you put it under here. And then letter E. 32 is 2 to what power? 5. You got it. The number line is here. You're going to see as we go along to kind of just get you thinking about the position on the number line of these beyond just seeing the symbol for a number. Okay, here we go. Let's see how quickly you can do this one. So don't answer the whole thing at once. Okay, Alec? All right. Letter A. You have log base 7 of 7. What? There you go. 1. Letter B. Also 1. So if you notice that the base of the logarithm matches the input number, you should be getting an answer of 1. Now look at C. Good. Because what it's asking is if your base number is 11, and now I'm not going to color code, what exponent do you have to have on that 11 to get an answer out that is 1? And that would be 0. So C is going to go here at 0. And what's D? Also 0. So what you want to get out of number 3 is if you have an input in your logarithm and the input is the number 1, you will get 0 no matter what the base is. If your input number matches your base, the answer is 1. You want to be aware of that. And then the textbooks usually make both of these individual properties for you to memorize. You can, if it helps you, you can write these down and memorize them. But what I want you to know is you're going to have a lot of other things to memorize in log rules. You want to understand why they work, and then you don't have to memorize more rules. Oh, we only have 5 minutes left. Okay. So if you have log base b of 1, the answer is 0. If you have log base b of b, you have 1. You need to be familiar with these two, but again, if you are getting the idea of logarithms, you actually don't have to memorize those. Okay, now how many more examples did I have left? 4, 5, 6, 7, 8. Fantastic. That's because I was sitting around trying to figure out if you guys were actually all here.
Just Blanchard.
Yeah.
I started doing it before class, and I feel like most of them are the basics that you went over. But can you go over 5C?
Yes. Yes. Thank you. Yeah, that's where some special stuff comes in that you would like to hear before you leave. So let me just start off with this. Letter A. 4 to what power is 16? 2. 2 to what power is 16? 4. I'm going to skip C. In D, 16 to what power is 16? 1. Now I'm going to go back to C. C is the first time you're running into not being given a nice number to work with. When you read log base 8 of 16, what you want to think is if I have an exponential with that same base, base 8, what exponent will give me 16? What I want you to be able to do is figure out where on this number line approximately does that lie. And okay, Dylan, that's fine. I want you to see that I don't want you to necessarily figure out that it's 1.5 or a half or what, but actually, Jason, that's what I'm looking for is just between integers. You know between integers, but you don't have enough experience with logarithms yet to know how balanced it is between them. So I want you to think about 8 to the 1 power gives you 8. 8 squared gives you 64. So basically, this is somewhere between 1 and 2. I don't need you to know where in between them, but just that it's in between them. So just put it somewhere in here. That's it. Somewhere in between there.
So that's what we would do for the rest of them that are uneven like that?
Right. You're just trying to figure out, and if you kind of make a table for that particular base and exponents 1, 2, 3, or -1, and so on, you're just trying to figure out the number that they are putting in the logarithm. You want to find an answer that is smaller and an answer that is bigger based on consecutive integers being put in as exponents. And that's what's going to get you through the rest of the problems. Yes, so I'm going to go over number 6. That one is where it gets hard. For part A, you're looking at 2 to what power gives you 5? Well, nothing specific. So let's look at 2 to the 1, 2 squared, 2 cubed, and so on. 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8. Where does 5 lie between? 5 is between 4 and 8. That means that the logarithm is between 2 and 3. I don't need you to know where between 2 and 3, just that it is between 2 and 3. Then for the next one, we have base 5. 5 to what power is 10? Or really, 5 to what power is smaller than 10 and 5 to what power is bigger than 10? And so you maybe start 5 to the 1, 5 squared, and maybe you just see it right away. 10 is between 5 and 25. So that means that this logarithm is between 1 and 2. Where between 1 and 2? That's not your concern right now. Okay, class time is over. You can go. I'm going to keep talking through the rest of the problems, and then I will post that video. Yeah.
I have a quick question on the homework. It's just like it says log of x, and then there's a big X. What would be the answer to that? Because there's no numbers. It's just.
Oh, yeah, I wanted to also mention this other thing, but oh well. Which number?
It's 3e and then 4e2. I don't know what the X.
Okay. And let me see. Oh, okay. So the x's are just, you don't know what it is, but you're still looking at what is the answer to the logarithm. Really what it's saying is, if the base and the input are the same, what's the answer?
What if it's like, oh, 1?
Yeah.
Oh, okay.
And while it's not saying it, there's an understanding that the X is only representing numbers we can actually use here. And then for this one, it's really looking at the base. If the base is X, what exponent will give you 1 over X squared?
Thank you.
Yeah. And for those of you that are still here, I do want to point out to you, unlike homeworks I've given you before, when you hit number 7, B is using A and translating it, but C is not using B. C is actually translating A as well. And what I want is for you to see the difference between these two. And I want to talk about it tomorrow with you, about what that difference is. So yes, school is over. You are free to leave. I'm going to finish talking about this and going through the examples, if I can find where I was. Nope. Where was I? Okay. So I've gone through A and B. For C, you want to start looking at, hey, if you put 1 into a logarithm, the only thing you're ever going to get out is 0. It's the reversal of if your exponent is 0, the only thing you get out is 1. So C is going to go where the 0 is. For D, you want to see that when these match up, that's always going to give you an answer of 1. But realize that that's because this base number being 5, what exponent does 5 need to have to be 5? 1. And then E. E is a little bit challenging. It's asking 10 to what power gives you an answer of 5. So you start thinking, well, 10 to the 1 gives me 10. That's too big. If I go to 10 squared, that is certainly not going to take me the direction I need. So let's go backward to 0. 10 to the 0 is 1. 5 is a number between 1 and 10. That means that the answer to the logarithm is between 0 and 1. And so you're just going to put E somewhere between 0 and 1. You don't need to know where exactly. And I'm going to keep going, but I'm going to go a little bit faster. Number 7, 10 to what power gives me 50? So I'm going to think through 10 to the 1 gives me 10. 10 squared gives me 100. 50 is between 10 and 100. So my logarithm is between 1 and 2. And I'm going to put letter A between 1 and 2. And it's not halfway, but right now I don't want you to concern yourself with who is it closer to, 1 or 2. Right now, don't worry about it. Part B, 10 to what power is 150? Well, let's see. 10 squared is 100. 10 cubed is 1,000. 150 is between 100 and 1,000. So that means that the logarithm is between 2 and 3. For part C, 10 to what power gives you 1,000? Ding, ding, 3. And then lastly, D, 10 to what power gives you 500? Like letter B, 500 is a number between 100 and 1,000. Comparison-wise, if I have an input of 150 for B and an input of 500 for D, which one's bigger? And hopefully you see that D is bigger. So I'm just, you could squeeze D in there, but I wanted to just kind of write it a little bit more nicely of, hey, D is bigger than B, but they're both between 2 and 3. Number 8. With number 8, this one's actually a slightly easier one, because you need to start seeing that if the base of the logarithm matches the base of the exponential, the exponent itself is the answer to the logarithm. This is 2. Here, same thing, the base matches with the logarithm and the exponential. That exponent is the value of the logarithm. Same thing with C. So that exponent is the logarithm. D, also the bases match, so -1 is the value of D. E, the bases match, so that means the logarithm has a value of 3, so E goes there. Then I did not, I think that was the last example, but I skipped over number 4. So let's take a look at 4 real quick. With number 4, we have the base is 2. 2 to what power gives me 1/4? And you want to see that you need a negative exponent to get the fraction. 2 squared gives you 4. So -2 is the exponent that needs to be here. So A is -2. For B, 10 to what power gives you 1/1000? And you want to see, maybe first you see that you need to put it to a negative exponent, but then ask yourself, if I didn't have to do the negative exponent, what power do I need to put on 10 to get 1000? And that would be 3. If that 1000 is in the denominator, that means -3 because the number's on the wrong side of the fraction. A logarithm becomes negative when it has a number on the wrong side of the fraction, so to speak. So that one is -3 for B. For C, 5 squared would give me 25, but wrong side of the fraction means -2 for the exponent on 5. And then lastly for D, 6 to the -1 power gives me 1/6. And that gets you through all of the problems in the classwork. So I hope that helped, and I'm going to stop this, and if you have